So let's look at this next example, and we're still solving equations with rational expressions. And you can see this one's gotten a little bit more complicated, but notice something. I have p squared plus 2p minus 35. Now look at these two here. Notice these are the factors of p squared plus 2p minus 35. So that's always going to be a good clue, is that these will usually be the factor of this. So that makes your life a lot easier. So, first step was we do factor. So my LCD here is p plus 7 times p minus 5. I'm going to just note here that p cannot be equal to a negative 7 or a positive 5. And now I want to go through and multiply each term on both sides by the LCD. So these get kind of long, so I'm going to try to make a little extra room here. And I'm just going to stick these right up in the numerator, just so we can save some room here, save a little real estate. Tell you get writer's cramp writing all this stuff out. So on the first one, p plus 7's divide out and the p minus 5's divide out, I just get 4. On the second one with a p plus 7's divide out, we get a times p minus 5. On the last one, the p minus 5's divide out, we'll get a negative 4 times p plus 7. And so now we're just going to work on distributing, combining like terms, and solving. So I'm going to distribute the 8. So that'd be 8p minus 40. And then we're going to distribute that negative 4. Make sure you include the negative when you distribute it. So that'd be negative 4p minus 28. Combining like terms, we get 8p minus 4p is 4p. Negative 40 and negative 28 is negative 68. I'm going to go ahead and add 68 to both sides. So that'd be 72. And then we're going to divide both sides by 4. And that should give us p equals 18. Now the nice thing, it does not match our restrictions, so that's good. So 18 is probably going to work, but let's check the answer. Again, I do not want to do this by hand. Go back to my original equation. So I'm going to use my calculator. So let's first do the left side. So I'm going to do my fraction key 4 over parentheses 18 squared plus 2 times 18 minus 35. Now you really see why I didn't want to do that by hand. Look, that's an ugly fraction. Now let's check it with the right side. So I'm going to do 8 over 18 plus 7, subtract fraction key 4 over 18 minus 5. I get the same thing 4 over 325. So it does check. So my answer would be 18. Let's try this next one. Looks like there should be a space there. But that's okay. So we can guess that x squared plus 3x plus 2 is going to factor into x plus 2 times x plus 1. So I'm just going to write that out. Slide this over. My LCD here is going to be x plus 2 times x plus 1, meaning my restrictions, x cannot equal to -2 and -1. So now I'm going to multiply by that LCD. Again, I'm just going to stick it in the numerator. So on this one, both factors divide out, just leaving 8. On this one, the x plus 2's. That gives me 9 times x plus 1. And here, the x plus 1's, plus 8 times x plus 2. We give a minute for the blood to get back into our hand after writing all that. Take a deep breath. And then we're going to distribute. So this would be 9x plus 9. That's 8x plus 16. Combining like terms, that would be 17x plus 25. And now we're going to solve this. We're going to subtract 25 from both sides. That will give us a -17 equals 17x. And then we divide by 17. That gives me x equals -1. Now we're in trouble though, because remember what we said, x was not allowed to equal to -1. This is a false solution, what we call an extraneous solution. So we run into trouble up there. So that means this thing has no solution. It's very frustrating to go through all that work and you end up with no solution. So let's turn the page and let's look at some applications. So let's suppose that 40 deer are introduced in a protected wilderness area. The population of the herd P can be approximated by P equals 40 plus 20x, all divided by 1 plus 0.05x, where x is the time and year since introducing the deer. Determine the time required for the deer population to reach 175. So we're going to be doing is setting this equal to 175 and solving. Now, our LCD is 1 plus 0.05x. Now, I'm going to argue that we really don't have to worry about the restrictions. And here's why. If I look at 1 plus 0.05x equals 0, where the values of x will look at the denominator, I want to solve that. I subtract 1 from both sides. And if I divide that by 0.05. That's going to give me x equals negative 20. Think about what that means in terms of this problem where x is the time in years. We're not able to go back in time. The domain here has an automatic restriction that my x has to be a positive number because we're talking about x as time. We can only go forward in time. So if I get a negative number, I already know it's not going to work in this problem. So I don't really need to keep track. I mean, you can. There's nothing wrong here saying x cannot be equal to negative 20, but it can't be equal to a negative number of 0, period, anyway. So now we're going to multiply both sides by the LCD. So on this side, these are going to divide out to 1. And then we distribute the 175 to both terms. So 175 times 1 is 175. 175 times 0.05. Well, you can do that real quick on your calculator. $8.75 equals 40 plus 20x. So let's do this. Let's get the x's on the left side and the numbers on the right side. So I want to go ahead and take away 175 from both sides. And I want to take away 20x from both sides. So those go out. We do that subtraction, that gives me a negative 11.25x equals, this would be a negative 135. And now we just need to do the division. So I'll just do it as a fraction, in fact, negative 135, whoops, over and negative 11.25. That works out to be 12. Doesn't match the restriction, so we're good. That means it's going to take 12 years. Let's try this next one. Starting at rest, the truck's velocity v is given by v equals 180t all over 2t plus 10, where t is the time in seconds after the car begins forward motion. So I guess we should change that to truck. So there's a typo. Determine the time required for the truck to reach a speed of 65 feet per second. Okay, so we're just going to go ahead and set that 180t over 2t plus 10 equal to 65. My LCD, yeah, that's supposed to be a t there. Let's make sure, there we go. My LCD is going to be 2t plus 10. Again, I can note the restriction, though, in the contents of this problem, it's not going to make a difference because my time can't be negative. But again, it's kind of the same idea as that we're saying that we're looking at where 2t plus 10 equals 0. That would be where it's undefined. Subtract 10 from both sides and then divide by 2. That would give me negative 5. So in other words, I don't want t to be equal to negative 5. And again, that's not going to happen because with time, you know the time has to be positive. So let's go ahead and multiply both sides. by that LCD. So on this side, those divide out. We get 180t equals, distribute to 65. That's 130t plus 650. We're going to subtract 130t from both sides. That gives us 50t equals 650. And now divide by 50. That gives you t equals 13. So that would be 13 seconds.